Hello and welcome to Mrinal's Math Tutorials. In today's tutorial, we are going to look at some questions on sine and cosine rules in trigonometry. How do we apply sine and cosine rules in non-right triangles? So let us start with sine rule. So let me draw a triangle. So a sine rule is used in a non-right triangle. That is the first thing that you have to remember, that it will be used only in a non-right triangle. So let's label this as A, B, C, and opposite to the angle B, let's label the side as small b, opposite to angle A, small a, and opposite to angle C, we'll label it as small c. Now, how do we apply the sine rule and when do we apply the sine rule? The sine rule can be used to find missing angle or a missing side whenever you have two sides and two angles given to you. You have two sides and two angles. Any one of them can be missing. So let's write down the rule. If you're finding the side, it is easy that you put the side on the top. So A over sine A, capital A stands for the angle, is equal to B over sine B, is equal to C over sine C. Remember, you will be using any two at a time. You will not be using all three, so you might be using these two or these two, or maybe the first and the last. If you're finding an angle, it is easier if you write the angle on the top. So I might write sine A over A is equal to sine B over B equal to sine C over C. Right? So this is all about the sine rule. We'll see how to implement it. Let us understand the cosine rule. Let me just add a page. So again, cosine rule, use it to find a missing angle or a missing side whenever you have been given three sides and one angle. Any one can be missing. Any one of them can be missing. So let us write down the rule. Let's draw a triangle. Again, it is similar to what we have drawn earlier, and the labeling also would be the same. How to actually apply it in the question, we will see some questions and you'll understand better. So A, B and C. Opposite to A is A, B and C. Let's mark A, angle A. So if you're finding the side, let's say you're interested in this side, okay, then we will be focusing on this angle which is opposite to it. So it would be A square equal to B square plus C square minus 2BC cos of A. If you are interested in finding the side B, in that case it is going to be B square and cos B over here. Yeah? According to what you want to find, you can manipulate the formula. And if you're finding the angle, of course you can use the previous formula that I've given over here, but it is good idea to memorize the one which is already rearranged for you. Cos of A would be equal to B square plus C square minus A square divided by 2BC. So that's about the cosine rule and the sine rule over here. So sine rule, again, we use when you have two sides and two angles. Any one of them can be missing. And cosine rule you'll use when you have three sides and one angle. Any one of them can be missing. Let us look at one of the examples now. Let's call this as example 1. Now here we have triangle ACB, and it is given to us that side AC is 8, side AB is 13, and the angle between them is 79. We have to use cosine rule to find or calculate the side BC. So this is the side which is missing. Yeah. So let's label the missing side as A because it's opposite to angle A. Yeah, it's opposite to angle A. Let me make use of a different color so that it's kind of visible. So let's call it as A. So we're going to use the rule A square equal to B square plus C square minus 2BC cos of A. So it doesn't matter really what is a B and C, but since it's already ABC, we can label this as B and this as C. Substitute in the formula. So BC square is going to be equal to 8 square plus 13 square minus 2 times, I'm just going to write everything in the bracket, 8 times 13 times cos of 79 degrees, and I will calculate all of it together with the square root or sine so that I have the accurate answer. It's a good idea to put a bracket around here so that you don't mess up in your calculations. Use your calculator and calculate the answer. So that's going to be equal to 13.9, correct to 3 significant figures. Now we need to calculate, use sine rule to calculate angle ACB. So ACB, because we have seen the center, the angle is at C. Now here we can, it's said to you that you have to make use of sine rule. So we have sine of ACB over the opposite side, which is 13. Yeah, sine A, okay, let's write down the rule first. So sine C over C is equal to sine A over A, because we have over here, we need to calculate angle C and we have angle A, right? It doesn't matter which one you write first. So sine ACB divided by, we can see that the opposite to the angle, opposite to this angle, the side is 13, divided by 13 is equal to sine 79 divided by the one which you just calculated, A, which is 13.9. Rearrange this, so it gives me sine ACB cross multiplying times 13.9 is equal to sine 79 times 13, or sine ACB is equal to sine 79 times 13 divided by 13.9. Of course, you can come straight to this step. So angle ACB would be then sine inverse of sine 79 times 13 divided by 13.9. So it's necessary that you do all of it in one go so that you don't have any rounding errors. So sine inverse of sine 79 times 13 divided by 13.9. This works out to be 66.6. Remember, the angles need to be accurate to one decimal place. So this is how you can solve or apply the sine and the cosine rule. Let us look at another example to understand it. Now, question 2, we have a triangle and it is given to us that one of the sides is 12, the other side is 8, one of the angle is 39 and the other angle is x. Now you notice that you have been given two sides and there are two angles. Two sides and two angles, that means which rule are you going to use? Two sides and two angles. We are going to use the sine rule. So it's important to notice that they're asking you to find or calculate the obtuse angle. We'll come back to this. What does it mean and to calculate an obtuse angle? Let's just apply the sine rule. Sine A over A is equal to sine B over B. I have written the sine on the top because I want to calculate the angle. So that's going to be sine x. Opposite to the x is 12 centimeters. So that would be divided by 12 equal to sine B, which is 39 degrees, divided by opposite to 39 degrees is 8 centimeters divided by 8. Again, cross multiply. You're going to get sine x times 8 equal to sine 39 times 12. So sine x is equal to 12 times sine 39 divided by 8, or we can say x equal to sine inverse of 12 times sine 39 divided by 8. Use your calculators to work this out. So this works out to be 70.73. Remember, the question is asking you to calculate an obtuse angle, but the one which you have calculated is an acute angle. In that case, always whenever they ask you to calculate the obtuse angle, it is always equal to 180 degrees minus the acute angle that you have calculated. Always. So 180 minus 70.73, it gives you 109.3 degrees, correct to one decimal place. Angles are accurate to one decimal place. So if they ask you to calculate an obtuse angle, you do apply this normal sine rule, and then if you get an acute angle, of course you'll get an acute angle, that's why they mentioned obtuse angle. You would do 180 minus the acute angle that you have obtained to get the obtuse angle. Alright, let us look at the next example. question 3. What do we have here? We have in the diagram BC, which is this one, is a vertical wall standing on a horizontal ground AB. So this is the ground and this is the vertical wall. Point T is a point on AB where A to D is 58 meters. Angle of elevation of C from A is 26. So what does angle of elevation mean? The angle of elevation means that from angle of elevation of C from A. So if you are at A, you want to look at C, the angle that is created from the surface, this angle is called as angle of elevation. So when you're looking up, the angle of elevation is created. And the angle of elevation of C from D is 72. So if you are at point D, you want to look at point C, the angle that is created is 79 as you're looking up from the horizontal surface. Now, we need to show that AC, that is this length, is 76.7 meters, correct to 1 decimal place. Alright, I can see that I have been given one side. I want to calculate this side. So if I already have two sides. If I can manage to get two angles, then I can use the sine rule. Of course, I cannot use the cosine rule over here because I have one angle, but I have only one side been given. To apply cosine rule, I would need three sides. One of them can be missing. So I'm interested in this triangle. I have two sides, one of them is missing, and I have one angle. So if I can manage to find this angle, I would be able to apply the sine rule. Now you can notice that it's a straight line. So this total angle is going to be 180. So I can very well calculate the angle ADC. This one, it is going to be 180 minus 72 degrees, which is equal to 108 degrees. So that is 108 degrees. Now we can apply the sine rule in this triangle with the two angles and one side. This side is missing. Yeah. So if I want to apply the sine rule, again, I would need this opposite side, which I don't have, right? So can I then, I have this side, can I calculate this angle? Because it would be then very easy for me to apply the sine rule. Okay, so what I'm going to do is, I'm going to use the definition of a triangle, that sum of all its angle is going to be equal to 180. So I can say that angle ACD is going to be equal to 180 degrees minus 26 plus 108. So what I've done is, I'm trying to calculate this angle within this triangle. I know the two angles. So 180 minus the other two is going to give me the angle ACD, which is going to be 46 degrees. So this angle is 46 degrees. Now let us apply the sine rule. Since we are finding the side, so the missing side is going to be on the top. So let's call it as AC. Now AC is opposite to this angle. So it's going to be AC divided by sine of 108 is equal to the one which is given to us, 58 meters. So 58 is opposite to this angle. So 58 divided by sine of 46 degrees. Now cross multiply. So AC times sine 46 is equal to 58 times sine 108. So AC would be equal to, let me just write down on the side, AC is equal to 58 times sine 108 divided by sine 46. And we need to calculate it to one decimal place. So 58 times sine 108 divided by sine 46. This works out to be 76.7 meters, which we had to prove. Alright, that's part 1. Part 2 is asking us to calculate the length BD. So we are interested in the length BD, which is this length. Alright, so how would we calculate the length BD? Of course, I know AB is 58. So somehow, if I can calculate this entire length, then I would be able to calculate BD. So I'm just going to look at this triangle once again. I now know the length AC is 76.7. So let me just copy this triangle down there. So I'm going to now try and use the full length, this full big triangle that I'm looking at. Yeah, I know that this is 76.7 and I'm going to try and calculate this entire length. So it's like thinking about SOHCAHTOA. You have this angle, yeah, and you have the hypotenuse, which is 76.7, and you want to calculate the adjacent side, because opposite to the angle, this side is the opposite one. So this is the opposite side and we need to calculate the adjacent side, right? So if I write down SOHCAHTOA, it is going to be equal to, we need the adjacent side and we have been given the hypotenuse. So we have hypotenuse and the adjacent side. So it is going to be cos of theta. Yeah. So let us apply that. So cos of 26 is going to be equal to adjacent side divided by the hypotenuse. So the adjacent side is missing, which is the full length AB, and the hypotenuse is 76.7. Cross multiply to calculate AB. So AB is going to be 76.7 times cos of 26. So let's calculate that. It works out to be 68.9. Now, to calculate the length BD, BD is going to be the full length AB minus AD, which is 68.9 minus 58. That is equal to 10.9, correct to 3 significant figures. All right, so this is how you would work out part 2. In this question was pretty interesting because you have used the sine rule, and you have managed to also calculate the missing length BD by using SOHCAHTOA. Somebody might have thought of calculating this particular angle and then using the whole length over here, or whole angle here, to calculate the opposite side using sine rule. That is also one of the ways, but I think what I have used is much easier compared to the cosine rule that could also be used. All right, let's look at the next question. That would be question number 4. Now this kind of a question is pretty common. You would have this kind of question in your IGCSEs. We need to find the length AB over here. Let us read what has been given. The diagram shows two triangles, ABD and BCD, and AD is 16.5, BD is equal to 12.4, angle ADB is 64, angle BDC is 53, angle DBC is 95. We need to calculate the length AB. We need to calculate this length. All right, so if you're calculating this length, you are interested in this triangle. In this triangle, you want to calculate this length, and you also have two sides. One side is missing and one angle. So you have basically 3 sides and 1 angle. So you're going to use cosine rule. All right, so let's make use of cosine rule. So so this is the opposite side. So let's call this as the missing one. Let's call it as A, or you can also call it as, it's opposite to the angle D, so let's call it as D. Yeah, so the rule is A square is equal to B square plus C square minus 2BC cos of A. Now this is a general rule. You need to apply it according to your need. So you're calculating A, then here we should have cos of A. Now in this case, you're calculating a D, so it should be cos of D. And this would be your other 2 sides, right? So we would write this as AB square equal to, make use of the other 2 sides. The other 2 sides are going to be these 2. It doesn't matter which one is B and C. So it's going to be 16.5 square plus 12.4 square minus 2 times 16.5 times 12.4 times cos of 64. So AB is going to be equal to square root of 16.5 square plus 12.4 square minus all that. Remember, the side that is missing, opposite to that, whatever is the angle, the missing side, opposite to that, that angle should be written over here. Okay, so AB works out to be, use your calculators, 15.7, correct to 3 significant figures. This is going to be 15.7 centimeter. Now part 2 is asking us to calculate the length BC. So let's look at our triangle again. We want to calculate the length BC. BC is in the other triangle. So what do we have in the other triangle? We want to calculate this length. We already have one length given, and we have 2 angles. 2 angles and 2 sides. One of the sides is missing. We're going to make use of sine rule. Now let's see if we can apply the sine rule. Remember, the angle and the side should be opposite. So we want to calculate this one. We have the opposite angle. Now this angle is being given, but this side is missing. right? So if two angles are given to you, you can easily calculate the third angle because it is angles in a triangle add up to 180. So calculate the third angle and then make use of that angle with 12.4. Yeah, so the first step would be to calculate this third angle. So that is going to be 180 minus, I'm just going to work it out over here. This is going to be 180 minus 53 plus 95. This works out to be 32 degrees. So let's make use of that to apply the sine rule. Okay. So we want to calculate BC. So BC divided by sine of 53. So BC divided by sine 53 is equal to the other side, which is 12.4 divided by sine of 32. 12.4 divided by sine of 32. Cross multiply and make BC as the subject. It's equal to 12.4 times sine 53, or BC is equal to 12.4 times sine 53 divided by sine 32. So let's work this out. 12.4 times sine 53 divided by sine 32 would be equal to 18.7 meters. Correct to three significant, centimeters, correct to three significant figures. Alright, that's it about this video. So we have looked at sine rule, cosine rule, and we also briefly looked at how to use SOHCAHTOA, and hopefully you found this video helpful. Thank you for watching. Thank you for watching the tutorial. Make sure you like, share and subscribe my channel.